All right, I got 3 or 4 different type problems to go over. Now, we've already done some of them. I threw about 3 tank problems in because I want you to mark them in your book. So when we come back to them in Calc 2, y'all won't be like, okay? The first one is the ladder. And the ladder is 20 foot long and is being pulled away at 1/2 foot per second. And they want to know what is the downward rate at 12 feet when x is equal to 12 feet. And I'm trying to pull up the whiteboard and it's not coming up. Oh, Sketchpad is back. Yay! Yes, come on in. Oh, you were getting us breakfast? Well, thank you. Don't call me up. Mr. Brooks is getting it. That's okay.
Yeah, man, I just need your card real quick.
He done got used to using that card. He sounds like a wife. I just need your card, you know. Let's go with, let's try this again. I'll try to be optimistic. I don't know how many of you are actually working the homework. We could look on the grade book and embarrass everybody. But what have you noticed, those of you that's actually done more than 3 problems, have you noticed anything about doing some of these problems?
They're all kind of different.
Well, that ain't what I was looking for, but yeah, they're all different.
You do a lot of homework.
But what, shut up. But what do you notice about the problems as far as methodology? Y'all don't know what methodology is.
It's the study of methods.
Okay, whatever. Do you notice the different problems have the same what? You have pretty much the same steps. You'll see it maybe after you do these because none of y'all have done the homework probably. Maybe 3 of y'all have done the homework. So, x at, what did I say, 13 feet, 12? And this is y, and we're wanting dy dt. All right, so there's your problem. Now, the first thing I want you to do, and yeah, if you want to go ahead and find y, go ahead and find y. Go ahead and do that. That's Pythagorean theorem. That's really not the central focus on this problem. If you want to go ahead and do it, go ahead and do it. You're going to need it. But the central focus is what are you going to use to take the derivative of? Well, you're going to use the Pythagorean theorem. Is there any other formula that you can use with the right triangle? No. So, you could divide this into 2 pieces. And let's just go over here and go ahead and get this out of the way. 20 squared minus 12 squared is equal to y. Well, I will say this. I think the do-jigger's writing better. What do y'all think? You don't have all them little...
Don't have a little things to see.
Yeah. Something happened. Somebody might have complained because I didn't, because I don't think it's going to get any better until they put that paint on this area. So that's the square root of 400 minus 144. And the square root of 256 is what, 16? All right, you got your algebra out of the way now. Everybody happy? Okay, now focus on the problem. And everybody feels good because they got that much done. first of all, write out the Pythagorean theorem, because you know that's what you're going to use. X squared plus y squared is equal to 20. Why are you not concerned about the 20? Why? Why does it zero out? Because it doesn't what? Maybe I need to pull out my CD.
Doesn't matter, does it?
Why?
Doesn't it?
Because the derivative of a constant is zero.
That's true, but why? Come on, I'm getting you to think. You're getting there.
Because it's like 20x to the zeros is 0 times 20.
That's right, but why? I'm talking about the actual problem. Think about what? No, well, you're getting there. All of you are getting there, but you're not. You're talking mathematics. I want you to talk. If you were standing there with that, pulling that ladder.
The ladder never changes.
What?
The ladder never changes.
The ladder never changes. Therefore, the derivative turns to what? 0. That's fine. Now, is that important for you to know? Yeah. Because you may be asked that in Calc 2. If you don't take my class, you may be asked that, and you tell them, say, I took a test in class, and that's where I learned it. That's what you do. I'm anxious to see if this works. You'll go ahead and finish the problem. If you can't, then just consider yourself a disappointment. Go ahead and finish the problem. Hit the wrong button. And that's going to be d dt of x squared plus y squared is equal to 20. Take the derivative of x squared in relation to t. Take the derivative of y squared in relation to t, and the square root of 20 is equal to 0. And then you've got what? What is that? Your formula to what? Plug and chug. IT informed me that the reason the license ran out is because nobody uses Sketchpad. Can't believe. The whole math department, nobody uses Sketchpad. Well, we got 2 math teachers that write their email in the subject line of their email. Can you believe that? Can y'all say dinosaurs? You know you're dealing with a technical advanced person when they put their whole email in the subject line. So I sent my reply in the subject line. How you coming? How you coming, Miss Anthony? You feel good about yourself?
Yeah. Because the lab was the one when I did. Because you told me there was a formula. It's always that one formula, so I could do that.
Okay, you got to think out of the box. I was opening Sketchpad. Is it not working? I have to pull it up through Sketchpad. Y'all great people. Sorry about that. I thought the sketch pad worked. All right. So $20. What did I say this was? 12, and this came out to be 16, and we're pulling at 0.5 feet per second. So that's going to give us dt of x squared plus y squared is equal to 20, and that's going to be 2x dx dt plus 2y dy dt is equal to 0. And what are we looking for? Well, we're given this. We're given this. We're given this. We get this. So what's the only thing that we could be looking for? What? Well, that's y direction, but it's the rate in the y direction, which is dy dt. Well, we go down here and we say to ourselves, well, we got dy dt right here. So, now you can simplify this, but I'm not going to. I'm just going to write it out. 2 times 12 dx dt is 0.5 plus 2 times 16 dy dt is equal to 0. What's half of 12? 2 times 6? And no, you don't need a calculator for this. Then I'll take the 12 across. You get 32 dy dt is equal to negative 12 divided by 32 divided by 32, and dy dt is equal to what, 3/8 feet per second. Isn't that nice? Making sure I got it right. Looks right. Y'all can check it. All right, got a nerd. Dang old shadow. Dang old light pole. Dang old use some straight lines. There's my light pole. Dang old sidewalk. I have noticed that a lot of the problems I pull out of the book or pull out of different books I got, all the man's always 6 feet. Don't know why. I think it's discriminating. I'm offended. And this pole was 22 feet.
Well, how tall are you?
I'm 6 foot, I think. I'm just offended because that's a society today, just to be offended to be offended.
Well, you know, you could probably sue somebody and win because that seems kind of stupid. So.
Yeah,
Yeah, the more stupid the lawsuit is, the more likely you are to win.
that's true.
It's like worth
Oops, sorry. Trying to draw this out nice and neat for y'all. Okay, let me ask y'all a question. 90% of the time, are they going to give you the height of the pole? Yes. So I want y'all to forget about Y being Y, okay? Because in a lot of the problems I researched, they call this bottom slice Y. You can call it what you want to. You can call it W if you want to for sidewall. You can call it, I don't call it S because I'm calling the shadow S. So I'm just going to write down here that this is X and this is S. And together, a lot of the books call this X plus S. They call that Y. Now, I'm going to say W for sidewalk. The only thing is, if you took the derivative in relation to time, it wouldn't be dy dt, it would be dw dt. But you're supposed to say w. When you say w, that puts you in the same category with the people that mispronounce OIL. And you don't want him Clemson with a P, so you don't want to be that way. So you make the effort to say W. Okay. Now the question is, a 6-foot man walks away from a 22-foot street light at 8 feet per second. Okay? 8 feet per second. It's got two parts. What is the rate of change of the length of his shadow at 19 feet? B, what is the rate that the tip of the shadow is moving? That's where you add them together. I think we did one like this the other day. So, A, what is rate of change? That's rate of change of length of his shadow at 19 feet. B, what is the rate of the tip of his shadow? Now, I tell students, when you see this question, it's not the length of W, but it's dW dt. And that's, I want you to think in terms of length of W. Okay? It's not the length. I mean, don't say X plus Y is equal. Don't do that. I don't want you to say it's the length. I want you to think in terms of the length when you think of dW dt. Now, what's the first thing you're going to do on this problem? What I tell you, the first thing you need to do on all your problems, find a what? Equation. Now, when you have these problems, the right triangle with the bigger triangle and smaller triangle, what is that? like triangles. So go ahead and put in your notes, when you have a shadow problem, you're going to use like triangles. You can set up like triangles as long as you're consistent. Do you have to set them up the same way as the person beside you? Yes or no? No. As long as you're consistent. If you pick the big end first and compare it to the little end, then you need to do that as far as the bases. You can't mix them up. So I'm going to say 22 is to x plus s as 6 is to what? S.
Are you not allowed to use W?
You can. But I'm not going to use that right now because the first thing we got to find is this. Which this pretty much is ds dt. And you can't do dw, you can't do dw dt unless you have what? Because we're given what? dx dt. Right there. Okay. We got the, so what's this rate going to be called?
Yes.
Trying to get you to see. And then what would the whole thing be called?
DW.
So the A is the dx.
Yes, it's always. Yeah. Because it's pulling along the what axis?
Right, but I didn't know that was the ds dt because it's like in.
Try to work with me here, Miss Anthony, okay? Yes, it is. Of course, if they gave you, if this was a ladder problem and they gave you this, what would it be? They gave you this on a ladder problem, what would it be? dy dt. Okay? They got to give you something, Miss Anthony. So, what do we do here? Cross multiply, Hubert. That's right, class. 22s is equal to 6x plus what? 6s. I'm going to bring the 6s over, and that's going to give me 22 minus 6 is what? 16. So 16s is equal to 6x. You can simplify that, or you can do it like that. It doesn't matter. I want you to finish it. That first problem we did, I got 2/3. Somehow we got 3/8. Y'all check my math on that and make sure I didn't mess up somewhere on that Latin product.
I got 3.
Okay, then I must have an error on my paper.
You have the 12 and 16 flip.
Huh?
You have the 12 and 16 flip.
Oh, is that what it is? Okay.
Yeah, I did that.
Okay. I did that just to show y'all that that's what could be done. Yeah, that's what I did. Yep. I suck. That was after 2 or 3 shots of Jim Beam. I'm sorry. I'm kidding. I'm not an alcoholic. I only drink in the morning. I knew a man that would drink a fifth of vodka every morning. I mean, not a fifth, but a little, what do you call it? Yeah. That's too hardcore for me. All right, so what do you think I'm going to do with this guy? After I got my equation, what do you do? Take the what? Derivative. So, because what are we looking for? That. Yeah, we're looking for that. We're looking for, what are these called? Well, the first derivative is called the what? The velocity, right? Yes? So, or acceleration. Which one is it? I think the first one is the velocity. So we're looking for this velocity and we're looking for that velocity. Do we see anything over here that has ds and dw in it? No. But we're... Okay, it's starting. We got two imaginary circles fighting down there. And we got one over here sitting by watching.
It's the gunfight.
Yeah, that's it. That was Ben Carson and the gunman, and this was somebody saying, "You stupid." The liberal media. That's who that was over there. Darn, how can we get that moved? Can't get it going again. All right, so dt of 16s equals 6s. And that's going to be 16 ds dt. Oh my, I think that's what we're looking for. Equals, that's supposed to be x, Hubert. 6 dx dt. And what are we solving for? ds dt. Hey, y'all sound like y'all know what y'all doing. ds dt equals 6 over 16 dx dt. And of course you can simplify this. ds dt is equal to 6 over 16, that's what? 3 over 8? Right? 3 over 8 dx dt. And we have dx dt. What is it? I'm not fussing because at least it's not making funny little marks. So ds dt, at least I know that I'm not going crazy. I begin to think I write that way. ds dt is 3/8 times 8 over 1. I need y'all to get y'all's calculators out. ds dt is equal to 3 feet per what? Okay, so we just found this guy. And what is that? That's his shadow. Yeah. Okay? Now, they want to know what? Yep, the rate. We found the length of his shadow, how fast we're finding at a certain foot or whatever, at 19 feet. What is the length of his shadow? How fast is it increasing? How fast is it increasing? 3 feet per what? Second.
So we just found the answer to A, right? Was
Yes.
that- Okay, now we're doing.
Yeah, that's why I was restating it. Yeah.
At the end there, what did
I
you
don't know.
plug in for dx dt?
Say again?
At the end, what did you plug in for dx dt?
You tell me.
Oh, the 8 feet. Okay.
Now, what is the second one? What is the rate of the what? So I'm going to take my handy dandy and I'm going to mark that dot right there. Because that dot is technically from measuring from the light to the tip of the what? Shadow. Okay? So you got to think in terms of that. That's what this is for right here. So this dot, can't get too close to it. That dot is being thought of from this dot. So B would be, excuse me, B, we need dW dt, right? Well, let's set up the equation. What's the equation for W?
X plus S.
W is equal to X plus S. And now that we've got our equation, huh?
That makes sense.
Okay.
That's so exciting.
Everybody see the light above her head? A little light bulb? That's a good moment when you see it. And then W dt is equal to dx dt plus what? And now what? Plug and chug.
So every time you get an equation, you just take the derivative.
If it's asking, now it's asking for the second part, this is the tip. So the tip, think of it kind of like, you remember the compass? Remember the compass you used in geometry? Y'all never used a compass? The pointy thing you stab people with. Look. Oh yeah, I know what it's talking about now. Think of it as you're putting the pointy end that you stab people with here, and the thing that looks like some kind of brace for a leg, you pencil, you put that thing in there, and you're drawing a what?
Circle.
Think of that in relation to velocity, not length. But you can think of it as length, but anytime, see, first of all, your length, X, Y, and Z, that's your hypotenuse. Z is your hypotenuse. This is your old algebra days, okay? And you're turning it into what? You're turning the lengths into what? Velocity, which means magnitude, which means direction magnitude, which means dang old vector. All right? So you're turning these guys into dx dt